All right, the last notebook we're going to cover today on Seaborn is on visualizing the distribution of a data set. So we'll go ahead and let me restart and clear the output. So we're going to look at a few different ways of visualizing distributions. Things like histograms and kernel density estimates and things like that. So here we have an array of size 100 that's normally distributed, and by default this function distplot will generate a histogram and a kernel density estimate. So this is a really nice simple way to see the distribution in a data set. With histograms, if we just want the histogram, we can turn the kernel density estimate to false, and we can turn the rug plot on, so rug equals true. That's this thing down at the bottom. This is related to those lines we saw in the violin plots a minute ago, where we see the actual data points. So it's a nice way to see where your data are. If we want to have some control over the number of bins, we can set bins equals to however many bins we want. In this case, instead of the default 10, we now have 20. Kernel density estimate, I'm not sure if you guys are familiar with, but this is a way of estimating the number of data points along a moving, a sliding window, and then displaying that as a curve. So it's a nice way to get to turn this sort of histogram into a single curve. If we turn the histogram off by setting it to false, the distplot will just show us the kernel density estimate. We've turned this rug plot on. If we want, we can shade it to see the filling. We can also control the bandwidth, which is how tightly that it fits that estimate. Effectively, just controlling like how tightly we want to fit that curve. And again, we can cut that curve at our data to avoid kind of it overlapping from overlapping to data that's not included in our data set. So we can change the fit model if we want to say to fit a parametric distribution. So here we're going to look at bivariate distributions. So this is how, rather than just looking at a single variable distribution, we're looking at how two variables covary. So a scatter plot is the kind of simplest way to look at that. So in Seaborn, a two-dimensional scatter plot is called a joint plot. So it's related to the scatter plot we saw before, but now we're specifically concerned with the distribution of the data. So it's going to give us histograms for the x and y that we can see at the same time as we see the scatter plot. So there's some additional flavors that we can use. We can use a hex bin plot, which will cluster the data into hexagons and then color them using a color map. So here we just have a black color map, but we could change this to blue is maybe a little prettier. It's the same data we have here, but it's kind of giving us a heat map, which we can also get a kernel density estimate of the same data, but this is using a two-dimensional kernel density estimate, so we have this nice curve around our data. And we also have the kernel density estimate of each x and y. So we also have the option to have rug plots, which here we're actually plotting separately, and we can see the contour as well. We can change the number of contour levels, or we can actually see this color map. This is the kind of thing we saw at the end of the matplotlib lesson. So again, we can use the joint grid object to have more control. So if we save, if we store this output of this plot, it will not only make the plot, but also store this handle that we can do things with. So we could add, for example, a scatter plot on top. So this is really nice because this is analogous to showing the say the box plot with the data points here. It's showing the contour kernel density estimate with the individual data points on top. So it gives us a lot of information about the data set. Finally, oftentimes you want to, this is really cool actually, you want to see multiple relationships in your data set. So you have multiple variables. Here we're going to use this iris data set. And if we use this pair plot function on the whole data set, what it's going to do is take each column in that data set. So we have sepal length, sepal width, petal length, and petal width. And then we can set hue equals species. And so it's going to show the pairwise relationship between each of those columns. So that's what we're seeing when we see these scatter plots. And then when we compare one column to itself, it's going to show the kernel density estimate, or that distribution. So we're getting both the pairwise relationship and the distribution. And we could cut off the top half of this because it's just duplicating what's in the bottom half. But depending on how you like to see it, right? So these are the same thing, etc. And then the hue is by species, so you can really see the differences in species. Especially say in petal width is the strongest differentiator, whereas sepal width is less easily distinguished. And similarly, this is built on top of the pair grid object, so you can store that as a pair grid object, and it gives you the ability to control some of the output. So for example, we can get a different dist plots. We can control the number of levels and the color map. So if instead of wanting to see a scatter, we see a contour map like this. So this one, I think this example in particular is really useful for examining your data. So for example, in that Earth microbiome project data that you guys are looking at for this week's homework, we did something like that using this kind of plot, and it really allowed us to see how the metadata kind of correlated across these different categories, and you could see which things were correlated and which weren't, and you could color by different categories. So that's Seaborn, and again, just like with matplotlib, I encourage you to go look at this gallery, and next time you need to make a plot, see what's there, and get some ideas that you can apply to your data. So and you'll get lots more practice with this stuff in your homework. So that is all for today.